Light. It's everywhere, and it's amazing. It lets us see the world around us, from the tiniest insects to the most distant stars. But have you ever stopped to think, what is light actually made of? It's a question that has puzzled scientists for centuries. Light is energy, pure energy, that travels in waves. These waves move incredibly fast at a speed of 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just 1 second. Light is essential for life itself. Plants use it to make food through photosynthesis, and we need it to see and to stay healthy. Without light, our world would be a very different place. So let's dive in and uncover the secrets of this incredible force. Light may seem simple, but it's actually made up of a whole spectrum of different waves, each with its own unique energy level. We can see some of these waves, and that's what we call visible light. It's the rainbow of colors we see when light passes through a prism. But there's a lot more to the light spectrum than meets the eye. Beyond red light are infrared waves, microwaves, and radio waves. These waves are longer than visible light and have lower energy. We use them for all sorts of things like cooking food, transmitting information, and even seeing through walls. On the other side of the spectrum, beyond violet light, are ultraviolet waves, X-rays, and gamma rays. These waves are shorter than visible light and have higher energy. They can be harmful in large doses, but we also use them for important things like medical imaging and killing bacteria. Have you ever wondered why a strawberry looks red or the sky looks blue? It's all thanks to the way light interacts with objects. When light hits an object, some of it is absorbed and some of it is reflected. The color we see is the color of light that is reflected back to our eyes. So a red strawberry absorbs all the colors of light except red, which it reflects. That's why we see it as red. Similarly, the sky appears blue because the air molecules scatter blue light more than other colors. This principle of reflection is what gives everything around us its color. It's like the world is a giant canvas, and light is the paintbrush that brings it to life. Section 4. Seeing the light, how our eyes capture the spectrum. Our eyes are amazing organs that allow us to see the world in all its colorful glory. But how do they actually work? Well, light enters our eyes through the pupil and is focused by the lens onto the retina at the back of the eye. The retina is covered in millions of light-sensitive cells called rods and cones. Rods are responsible for our vision in low light, while cones allow us to see color. There are 3 types of cones, each sensitive to a different range of wavelengths: red, green, and blue. When light hits these cones, they send signals to the brain, which interprets them as different colors. The combination of signals from all 3 types of cones allows us to see the full spectrum of colors, from the deepest reds to the most vibrant violets. Section 5. The wave-particle duality, light's amazing double life. Now here's where things get really interesting. For centuries, scientists debated whether light was made up of waves or particles. Turns out it's both. This is what we call the wave-particle duality of light. Sometimes light behaves like a wave, like when it diffracts through narrow openings or creates interference patterns. Other times it acts like a particle called a photon, like when it interacts with electrons and atoms. It's like light has a split personality. This duality is a fundamental concept in quantum mechanics, and it has revolutionized our understanding of light and matter. It's a strange and wonderful concept, but it helps explain how light can be so versatile and powerful. Section 6. Light's everlasting impact, illuminating our understanding. Light is more than just something that helps us see. It's a fundamental force of nature that shapes our universe and our understanding of it. From the moment the Big Bang bathed the cosmos in light to the way it allows us to communicate across vast distances, light plays a vital role in our lives. By understanding light, we gain insights into the workings of the universe, the nature of matter, and the origins of life itself. It's a journey of discovery that continues to this day, as scientists explore new frontiers in optics, photonics, and quantum physics. So, the next time you flip on a light switch or marvel at a rainbow, remember that you're witnessing something truly extraordinary: the power and mystery of light.